Hello, today we're going to talk about section 1.4 of the study guide in order to prepare for your quiz. So I will start with vocabulary. Potential energy is the energy possessed by a body by virtue of its position relative to others, stresses within itself, electric charge, and other factors. Basically, it's how much energy is stored in an object. Kinetic energy is the energy an object has due to being in motion. Thermal energy, the total energy of the thermal motion of all particles that make up an object. Temperature, the average kinetic energy of the random motion of all of the atoms and molecules in a body. Thermometer is a device used to measure temperature. Thermal equilibrium is when two objects are the same temperature and therefore no heat flows between them. Celsius is a scale of temperature on which water freezes at 0 degrees Celsius and boils at 100 degrees Celsius under standard conditions. Fahrenheit is a scale of temperature on which water freezes at 32 degrees Fahrenheit and boils at 212 degrees Fahrenheit under standard conditions. Conduction is the process by which heat or electricity is directly transmitted through a substance when there is a difference of temperature or of electrical potential difference between adjoining regions without movement of the material. Obviously, for this section, we care about the heat part of this definition. Heat is a form of energy arising from the random motion of the molecules of bodies, which may be transferred by conduction, convection, or radiation. Temperature difference, which is literally one temperature subtracted from another. If it is the same object being heated or cooled, it will be the final temperature minus the initial temperature. Calorie is the energy needed to raise the temperature of 1 gram of water 1 degree Celsius. British Thermal Unit, or BTU, is the amount of heat needed to raise 1 pound of water through 1 degrees Fahrenheit. Specific heat is the heat required to raise the temperature of the unit mass of a given substance by a given amount. Melting point, the temperature at which a given solid will melt. Boiling point, the temperature at which a given liquid will boil. Heat of fusion, the heat absorbed by a unit mass of a given solid at its melting point that completely converts the solid to a liquid at the same temperature. Heat of vaporization, the heat absorbed per unit mass of a given material at its boiling point that completely converts the material to a gas at the same temperature. We don't need to worry about this part. The short answer questions for the study guide. The thermal energy of a body is the total kinetic or thermal energy of all of the particles that make up the body. The temperature of a body is determined by the average kinetic energy of the particles that make up the body. A thermometer measures temperature in degrees Celsius or Fahrenheit, which is Fahrenheit. Number 4. Heat is the energy that flows from one body to another because of a temperature difference. Number 5. Whenever two bodies are brought together, heat flows from the body with the higher temperature to the body with the lower temperature. Number 6. The amount of heat transferred to an object varies linearly with the object's temperature change. Number 7. First of all, there should be another word in here. That. As long as there is no change of state for an object that is being heated or cooled, the heat transferred is given by capital Q is equal to mc, which is specific heat, times delta T. Number 8. If heat is transferred to a substance and it changes state, its temperature does not change. The first problem says a meteorologist forecasts a wind chill of negative 40 degrees Celsius. What is the predicted wind chill in degrees Fahrenheit? For this problem, we need to use the equation that temperature in Fahrenheit is equal to 9/5 times the temperature in Celsius plus 32. Our Celsius temperature is negative 40 degrees, so we substitute that in for the appropriate variable, and we have 9/5 times negative 40 plus 32. Calculating this out, we get that the temperature in degrees Fahrenheit is actually negative 40 degrees Fahrenheit. Number 2 says an oven is set to keep at 425 degrees Fahrenheit. What is the setting in degrees Celsius? For this problem, we're going to use the equation temperature in Celsius is equal to 5/9 times the quantity of the temperature in Fahrenheit minus 32. Making our substitution, we get 5/9 times the quantity of 425 minus 32. Calculating this out, we get 218.3 repeating degrees Celsius. Number 3 says a pot holds 4 liters of water. How much heat is needed to increase the temperature of water from 20 degrees Celsius to 100 degrees Celsius? In order to figure this problem out, we are going to use the equation heat is equal to the mass of the fluid times the specific heat of the fluid times the change in temperature of the fluid. To find the mass of the water, we need to use the fact that 4 liters is equal to 4,000 milliliters. We also need to be aware that the density of water is equal to 1 gram per milliliter. So if we have 4,000 milliliters of water, we have 4,000 grams of water for the mass. The specific heat of the water, C, if you don't know, can be found in your book. 1.00 calories per gram degrees Celsius. Lastly, the temperature change. The final temperature of 100 degrees Celsius minus the initial temperature of 20 degrees Celsius, giving us a temperature difference of 80 degrees Celsius. We make our appropriate substitutions. The mass is 4,000 grams. The specific heat is 1 calorie per gram degrees Celsius. And the change in temperature is 80 degrees Celsius. The degrees Celsius cancel out, the grams cancel out, and we are left with 320,000 calories of heat. Number 4 says a 2.5 kilogram iron ball at 100 degrees Celsius is placed in an insulated container of water at 10 degrees Celsius. When the ball and water reach thermal equilibrium, their temperature is 25 degrees Celsius. What amount of heat is transferred between the ball and the water? So in order to figure this problem out, I need to look at the iron ball. And I'm going to use the equation Q for heat is equal to the mass of the ball times the specific heat of iron times its change in temperature. The mass of this iron is 2.5 kilograms. Since specific heats are generally given in grams, I'm going to convert that to grams by multiplying by 1,000, and we get 2,500 grams of iron. So I will note that the mass of the iron that I'm going to use is 2,500 grams. I need to look up the specific heat of iron in our book, and the specific heat of iron is 0.16 calories per gram degrees Celsius. Lastly, I need the temperature change for the iron ball. So the change in temperature of the iron is equal to its final temperature of 25 degrees Celsius minus its initial temperature of 100 degrees Celsius, giving us negative 75 degrees Celsius. This temperature change is negative because the iron ball is being cooled by the water. Making our substitutions, the mass is 2,500 grams. The specific heat is 0.16 calories per gram degrees Celsius. And the temperature change is negative 75 degrees Celsius. The grams are going to cancel out, the degrees Celsius are going to cancel out, and I am going to multiply these numbers together and get negative 30,000 calories. Lastly, number 5 says a 100 million kilogram ice cube has a temperature of negative 5 degrees Celsius. How much heat is needed to melt the ice cube completely and raise the resulting water to 2 degrees Celsius? The first thing we need to do, because the specific heats and the heat of fusion are given in grams, is change 100 million kilograms, multiply it by 1,000 to change it to grams, and we will get 100 billion grams. Generally speaking, it's going to be easier to write that as 1 times 10 to the 11th grams in scientific notation. This problem follows very closely with example 1.17 in the book. So the first thing that we are going to do is we are going to calculate how much heat is necessary to raise the temperature of the ice from negative 5 degrees Celsius to 0 degrees Celsius. So we'll call this Q1. That's equal to the mass of the ice times the specific heat of ice times the change in temperature of the ice. The mass of this ice is 1 times 10 to the 11th grams. The specific heat of ice found in the book is 0.49 calories per gram degrees Celsius, and the change in temperature is the final temperature minus the initial temperature, 0 degrees Celsius minus negative 5 degrees Celsius. Calculating that out, we should get 245 billion calories. Part 2, we need to find how much heat it takes to completely melt this ice cube. And to figure that out, we need to use the equation for heat of fusion, which is the mass of the object times the heat of fusion. So once again, the mass of the object that we're going to use is 100 billion grams. And we're going to multiply that by the heat of fusion that is found in section 1.4 of your book for water, 79.8 calories per gram. Multiplying those together, you will get 7.98 times 10 to the 12th calories. If you want that written out as a number not in scientific notation, it's 7,980,000,000,000 calories. The third part, going from 0 degrees Celsius to 2 degrees Celsius, we're back to our equation that we've been using for most of these exercises. Mass times specific heat times change in temperature. Same mass for at this point, water, 1 times 10 to the 11th grams, times the specific heat of water, which we know at this point is 1 calorie per gram degrees Celsius, times the change in temperature, which is the final temperature of 2 degrees Celsius minus the initial temperature of 0 degrees Celsius. Multiplying those together, we get 200 billion calories. Finally, to get the total heat, it's equal to the 3 heats that we have combined, so Q1 plus Q2 plus Q3. And if I were to add those together, I would get 8,425,000,000,000 calories. Putting that in scientific notation, it would be 8.425 times 10 to the 12th power. Good luck on your test this week.